So this is lesson 2 for Math 156. So let's start by reviewing a little bit of what we did last week. And I'll do it with one of the homework problems. So we had the following quadratic equation. We want to plot and solve the equation the equation is x cubed minus 3 times x minus 5 equals 0. So to plot this, we just write down the function of x, comma x, and there's the plot. So the default in Maple is to plot, to graph a function from minus 10 to 10. That's what's going on here. And where it's crossing the x-axis is somewhere in this region, but you can't see it very clearly what's going on. So the smart thing to do, if we want to understand the graph of the function in here, is maybe plotted not from x equal to minus 10 to 10, but we can specify the range of the x-axis by writing x equals, and let's say minus 4 to 4. So you write minus 4, 2 dots, and then a 4. And now we get the graph from minus 4 to 4. So now we can see what's going on in here. And the cubic, as many cubics do, goes up, down, and up again. Now, if we want to solve the equation x cubed minus 3x minus 5 equals 0, that means we want to find the point where the graph crosses the x-axis. At this point, y is equal to 0. X cubed minus 3x minus 5 equals 0. So we can find the solution graphically. It's always a very good thing to do, by blowing up the curve right around this point. So let me just copy this. And let's say, so you can look at this, you see where it crosses the x-axis is between 2.5, between 2 and 2.5. So let's blow it up right there. So let's graph it, say, from 2.0 to 2.5. And now we see it's really crossing the x-axis between 2.25 and 2.3. So I'll just change the range of x. So you see now it really is crossing very close to 2.28. Maybe I'll put in 2.76 and 2.28. Let's see. So it looks very close to 2.279. Maybe I'll graph it between 2.278 and 2.279. So it's a little bit bigger than 2.790. And 2.279, make it 05. Wow. So here, just by blowing up, by magnifying the graph of the function around that point, we see where the curve crosses the x-axis is 2.790 something. I mean, we have it to 4 or 5 significant digits. Let me just change this one more time. 2.7902 and 2.7901. Wow. So there it is. That means 2.27901.8 something. Yeah. Wow. So just by plowing up, we have this, the solution of this cubic curve. Oops, I called this a quadratic, it's actually a cubic. To many decimal places. Now, we can also just use the fsolve command. Fsolve means solve an equation and give me the solution as a decimal. So fsolve, solve the equation. This equals 0, comma x, solve for x. So here we get the solution to 10 significant digits, 2.2790187. Yeah, it's consistent. Now, in plotting curves and in solving equations, sometimes we have well, a basic problem in high school algebra, for example, was to solve 2 linear equations in 2 variables. So let's see if I can write this down. So 2 linear equations in 2 variables. For example, suppose we have, let's see if I can write it, 2x minus 7y equals 13. And 5x plus 3y equals minus 2. So how do we solve 2 equations and 2 unknowns? So we can use solve or fsolve. Let's use solve. So when you're solving more than one equation, you put the 2 equations you're trying to solve in curly brackets. So in curly brackets, I have 2 times x minus 7 times y equals 13, comma, that's how you separate the equations, 5 times x plus 3 times y equals minus 2, curly brackets, comma. So those are our 2 equations, 2x minus 7y equals 13, 5x plus 3y equals minus 2. And I'm solving for 2 variables now, not just one. And I put the 2 variables I'm solving for also in curly brackets, parenthesis, semicolon. Ah, that's the answer. 2 equations and 2 unknowns, that's the answer. If we want the solution in as a decimal, we can do 2 things. So we can use the command to convert a number to a decimal, that's EVALF. And what I want to convert to a decimal is what I just calculated. So I can just use a % sign. And Maple converts these fractions to decimals. Alternatively, I could have used the command fsolve, which would solve this equation in decimals immediately. And we get, well, at least at 10 decimal digits, the same thing. So this is how you solve two equations in two variables. Suppose I wanted to graph these two lines. Now, how do I plot the line 2x minus 7y equals 13? In our plotting command, we've only been able to plot y as some function of x. We can't put in yet an expression that involves both x and y. So if we have 2x minus 7y equals 13, I want to solve that for y. And Maple will do that just using the solve command. If I write down solve this equation, solve that for y, I get y is equal to minus 13 over 7 plus 2x over 7. Let me give this expression a name. The way you name something in Maple is to say, well, let's see, suppose I just want to call it capital F. F equals, colon equals means this is how you assign the value of a variable to something. So I want F to be what you get when I solve this equation. So F is this expression. What about for my second function, my second straight line? If I solve that for y, and I'm going to call what I get, let's say capital G. So when I solve this equation for y, I get this. So now I have my two straight lines as functions. Y is a function of x. And let's say I want to plot these two functions together. So if you're going to plot two functions together on the same graph, you put the two functions in curly brackets. I could write f comma g, because those are the names of my functions. So plot this as a function of x, and there it is. Those are my two lines plotted together. You'll notice the x-axis is minus 10 to 10. The y-axis is roughly minus 17 to plus 16. If I wanted really drawn to scale, I can, let's see, it's always tricky in Maple to do. There we go. Click on scale and constrain. Now it's drawn to scale. In any case, this is the point where the two lines cross. What are the coordinates of that point? Well, we know what they are. We just calculated them. 0.6 and minus 1.68. Let's just blow that up, and so we can actually see it ourselves. So instead of graphing x from minus 10 to 10, let's graph x from, let's say, 0 to 1. That's what it looks like. And you can see the x coordinate is about 0.6, and the y coordinate is about minus 1.7. Okay. Just what we got here. Let's look at more interesting questions. Suppose we want to find the points where two parabolas intersect. So find using plot and also by using solve, or more often we use fsolve. The points of intersection of two curves. So suppose we take two parabolas. Suppose one of our parabolas is, I don't know, let's make it simple. Y equals x squared. So let's plot these two parabolas. One of them is x squared. And let's say the other is 3 minus 2x minus x squared. Wow, that's what it looks like. Right, I put the two curves in curly brackets, so this is y equals x squared, that's the red curve. And the blue curve is this parabola. And they intersect at these two places. Let's use just plotting to find at least approximately the x coordinates of these points of intersection. So if we blow up around this point is between 0 and 1. Actually, it's closer to 1. So let's go, maybe x goes from 0.5, 2 dots, to 1.2. Ah, okay. So here's where these 2 points cross. It looks like it's really between 0.8 and 0.9. Oh. So it's really more like between 0.82 and 0.84. In fact, really between 0.82 and 0.825. And maybe between 3 and 3.5. Oops, too much. Oops, still too much. Yeah. About 0.82, a little bit less than 0.823. Maybe I'll make this 0.8225. Yeah. So somewhere around 0.8229. No, that's good enough. That's this point of intersection. The second point of intersection is around -2. Maybe I'll graph this from -2.5 to -1.5. Aha. So this point of intersection looks like it's really between -1.9 and 1.8. Or maybe really between -1.83 and 1.81. Ah. Yeah, so it's roughly -1.823. Okay, now, so that's finding solutions graphically. Suppose we wanted to find the solution using fsolve. So we're doing the following: fsolve, solve the equation. So we want to know, when do these two curves intersect? For what value of x does x squared equals 3 minus 2x minus x squared? So we're saying to Maple, solve the equation x equals 3 minus 2x minus x squared. Solve it for x. And this is what we get. 0.822 and minus 1.822. 0.822 something. Yeah, exactly what we saw graphically. So that's very nice. Let's look at some other kinds of curves, not just polynomials. Maybe let's look at some exponential functions. Suppose I want to plot the function 2 to the x. That's what it looks like. Shoots up very quickly. Then you make it 3 to the x. Goes up even faster. Suppose I take two exponentials. Suppose I take 3 to the x plus 4 to the x. Ooh, looks like that. Suppose I take 3 to the x plus 4 to the x, and I also graph 5 to the x. I have these two curves. Where do they cross? It's hard to tell because here they're so small, they're so close together, you can't tell. Suppose I want to graph these two curves maybe from x equals 0 to 4. This is interesting. So they cross right there. What is that point? Let's blow it up a little bit. Looks like it's around 2, so maybe I'll graph it from 1.9 to 2.1. Wow. So one of these curves is 3 to the x plus 4 to the x. The other is 5 to the x. I'll graph from 1.99 to 2.01. Yeah, I get 1.999 and 2.001. Yeah. It looks like these two curves cross at x equal 2. Suppose I want to find exactly. Suppose I want to solve the equation 3 to the x plus 4 to the x equals 5 to the x. Solve that equation for x. Ooh, seems to be too hard for Maple. Let me use fsolve. 2. So what have we just seen? We've just seen 3 squared plus 4 squared equals 5 squared. Yeah. So that's a kind of a geometrical verification of a famous case of the Pythagorean theorem. Suppose we change this. Suppose we look at 3, 4, and 6. So let me go look at 3 to the x plus 4 to the x and 6 to the x. So they seem to cross somewhere between 1 and 2. Where is it exactly that they cross? 1.293. Suppose I made this 2 to the x. That's kind of, oops. Two to the x. That's curious. If I plotted these curves, looks like that. Yeah, they seem to cross down there. Oh, very interesting. So this is solving equations and solving multiple equations, plotting graphs of one function and of multiple functions. Suppose we had the following problem. Solve the equation x squared plus 7x equals n for all n from 1 to 10. So this is 10 quadratic equations you have to solve. And you could write down 10 equations. That takes a few minutes, not so bad. If you had to solve 100 equations, you wouldn't want to write down all 100. You'd just be repeating essentially the same thing 100 times. You don't want to do that. It's too much work. So in Maple and in most computer programming languages, there is a way to write what is sometimes called a loop. You can say, for n going from 1 to 100, do something. And Maple will do it if you give the right command. So let me show how you write a loop. So solution, use a loop. So there's certain words in Maple that are reserved. They come up in boldface. Here you see 3 words in boldface, for, from, and to. So here's the syntax for writing a loop in Maple. For, and now n is my variable, n from 1 to, let's just go up to 10 so we don't have to use up too much space. For n from 1 to 10, do. And now I want to move down a line. Now, if I just hit enter, it goes to another, it thinks that's the end of your command, and there's an error because this is an invalid loop. So the way you move down a line in Maple without Maple thinking you finish your command and you're asking it to execute is to do Shift Enter. You do Shift Enter, that moves the cursor down a line. And I'm going to indent a few spaces. So for each n, what I want to do is solve, let me use fsolve, solve the equation x squared plus 7 times x equals n for x. Solve that equation for x. I want to go down a line, so Shift Enter, and then I have to end. I write end do. Whenever you, for every loop, if you start with for n from something to something, do, and then when you're done telling it what to do, you have to write end do. So now let me press enter. And you'll see I have 10 lines. And for each line, I have 2 numbers. Why do I have two numbers? Because these are quadratic equations. Quadratic equation is two solutions. So for each n, I get the answer. I mean, that's really amazing. If I've made 100 here, oops, here's where I have to put in 100. I actually have 100 lines on my computer program. I just solved 100 quadratic equations. Let's see, if I put an n comma here, and I don't want to, I mean, this just takes up too much. I don't need all that. So I'll go back to 10. And I put an n here, so now I know for each, and this is just telling me for which n, which quadratic equation in n, this is the solution. So when n equals 1, it's this. Actually, let's just check. If n were equal to 0, x squared plus 7x equals 0 has solutions 0 and minus 7. So let me start this loop from 0. And I see for n equals 0, I get minus 7 and 0. Let's do another example. Find square root of n as a decimal. So I could say for n from, let's say, 1 to 10, do shift enter again, and do. I like to put that in always. Go back up and indent. What I want is the square root of n, but I want this evaluate as a decimal. So EVALF, evaluate as a decimal, square root of n. I write n comma, so I'll write n and then square root of n as a decimal. Let's see what we get. So square root of 1 is 1. Square root of 2 is 1.4. Square root of 3 is 1.7. Square root of 4 is 2, and so forth. It's pretty good. Yeah, if I wanted to go up to 1,000, I mean, I'm just making my computer work a little bit harder. This computer is slow, so it's taking a bit of time. There we go. In case you wanted to know, they're the square roots of the first 1,000 integers. Again, I don't need all of this on my screen. Let me go back to 10. There we go. Okay. So that is a loop. Okay. So that is the end of this lesson. And what I think I will do is in a day or two, post another lesson just to develop a little bit further some of the ideas about loops and solving equations and so forth. And I'll also post in a day or two a homework assignment for next week. That's it.